Welcome to our presentation on circular economy best practices in the European Union. Today, we are focusing on an exemplary case study. BioAzul and their P2 Green project based in Spain. BioAzul stands out as a pioneer in turning waste into a resource, specifically focusing on the agricultural sector. As we transition away from traditional linear models of take, make, dispose, companies like BioAzul show us the practical path forward. We will examine how their innovative approach to nutrient recovery not only protects our environment but also creates new economic value and supports social well-being across different European regions. Let's begin by looking at our roadmap for today's session. Our agenda for this session is structured into three primary segments to provide a comprehensive analysis of BioAzul's circular transition. First, we will cover the company profile, providing insights into their core business operations and the initial challenges that led to their circular strategy. Second, we will dive deep into the key components of circular economy practices. This section utilizes the KODECET framework to evaluate BioAzul's impact across three critical pillars: planet, profit, and people, alongside overarching themes like policy and technology. Finally, we will conclude with a summary of circular economy strategies. This will include an overview of the core technological recovery methods, the main findings from their recent project analysis, and the key takeaways that make this company a scalable blueprint for other sectors within the European Union. This structured approach ensures we understand both the why and how of their circular success. Company profile of BioAzul. BioAzul is a Spanish engineering and technology consulting firm headquartered in Malaga. While they operate globally, their P2 Green project involves a collaborative network across 13 EU countries. They are a leader in the fertilizers sector, but their expertise is broader, focusing on eco-innovative solutions for sustainable water resource management. Established as a pioneering firm, they have dedicated their efforts to addressing the escalating waste management crisis in Europe. Their work is characterized by high-tech engineering tailored specifically to environmental sustainability. The company's strategic location in southern Spain provides a unique vantage point for addressing water scarcity and nutrient depletion in semi-arid climates. By acting as a bridge between urban waste systems and rural agricultural needs, BioAzul exemplifies how specialized consultancy can drive systemic change. This overview sets the context for their specific circular economy initiative, addressing agriculture's most significant environmental hurdles. BioAzul's core business centers on sustainable water resource management through innovative engineering. Their primary circular economy approach is embodied in the P2 Green project, which targets the transition from linear to circular nutrient systems. This is achieved by recovering essential nutrients, specifically nitrogen and phosphorus, from human sanitary waste to create high-quality, bio-based fertilizers. This model strictly adheres to the reduce, reuse, and recover principles of the circular economy. The main findings from their recent CE analysis are impressive. They have successfully validated that advanced recovery technologies, such as struvite precipitation, can recover up to 75% of phosphorus from wastewater. These findings have been proven scalable through pilot projects across diverse European climates, ranging from the water-stressed Baltic Sea to the nutrient-depleted soils of southern Spain. This demonstrates that their circular model is not just a theoretical concept but a globally applicable reality. The initial situation that prompted BioAzul's circular transition is defined by a heavy global reliance on energy-intensive and expensive mineral fertilizers. Traditional agriculture follows a linear path that depletes finite mineral resources while simultaneously harming ecosystems through nutrient discharge, leading to severe pollution known as eutrophication in aquatic environments. Furthermore, industries face escalating costs for waste disposal and growing resource scarcity. Regulatory drivers have also played a crucial role. EU directives, such as the Urban Wastewater Treatment Directive, exert significant pressure on member states to improve waste management and resource recovery. BioAzul recognized these economic and ecological challenges as an opportunity to innovate. By addressing the take, make, dispose flaw in the agri-food supply chain, They aim to reduce dependency on imported minerals and create a more resilient food system that aligns with the European Union's long-term environmental sustainability targets. Key components of circular economy practices of BioAzul. Under the planet pillar, BioAzul's environmental impact is profound. Their recovery technologies drastically reduce nutrient discharge into water bodies, preventing the creation of hypoxic zones and protecting aquatic biodiversity. A key material innovation is their use of the Stuttgart process, which creates eco-friendly, bio-based fertilizers that replace traditional fossil-based products. Furthermore, their design for circularity ensures that these fertilizers are engineered for gradual nutrient release. This design improves plant uptake efficiency and minimizes waste compared to conventional fertilizers. By focusing on these indicators, BioAzul achieves a significant reduction in the total carbon footprint of the fertilizer lifecycle. They effectively conserve natural resources by decreasing the need for mined phosphorus and synthetic nitrogen. This multi-dimensional approach to environmental health ensures that their operations restore ecosystems rather than depleting them, fulfilling a core objective of the circular transition. The profit pillar examines the economic viability of BioAzul's circular model. Their strategy ensures long-term financial sustainability by transforming urban waste streams into valuable agricultural commodities. This creates new revenue streams from sustainably grown produce that meets the rising market demand for eco-friendly goods. For farmers, the transition provides significant cost savings, as local bio-based fertilizers offer a cheaper and more stable alternative to volatile mineral fertilizer prices. Logistical efficiencies also contribute to profit, as local production minimizes transportation costs and associated emissions. In terms of technology and innovation, BioAzul employs scalable bioreactors and specialized recovery processes like KREPRO that are adaptable to various regional infrastructures, ensuring the model's economic feasibility across different markets. This demonstrates that sustainability can be a primary driver of industrial competitiveness, proving that circular models can be both profitable for businesses and beneficial for the broader European economy. BioAzul's commitment to the people pillar focuses on social well-being and stakeholder engagement. Their projects stimulate local economies by creating new employment opportunities in fertilizer production, specialized logistics, and advanced research. Beyond job creation, their work enhances regional food security by fostering healthier soils and supporting higher crop yields through sustainable nutrient management. A cornerstone of their success is an extensive collaborative network involving 32 European partners, including universities, research institutes, local governments, and industry leaders. This stakeholder engagement ensures equitable knowledge sharing and community involvement across borders. They also prioritize education to build awareness about the benefits of bio-based fertilizers, fostering a culture of sustainability and responsible consumption. By integrating these social variables, BioAzul ensures that their circular transition is human-centric, promoting fair labor practices and community development as essential components of a resilient and equitable sustainable economic future. The overarching components of BioAzul's framework involve policy support and rigorous impact measurement. They maintain strict compliance with EU sustainability standards, specifically aligning with the Fertilizing Products Regulation to ensure market acceptance of their bio-based products. Their advocacy for circular governance helps create the necessary legislative frameworks for widespread industrial adoption. In terms of impact measurement and reporting, BioAzul uses standardized indicators to track recovery rates for nitrogen and phosphorus accurately. They also monitor carbon emission reductions and water quality improvements, providing empirical evidence to justify sustainability investments. This transparent reporting builds trust with stakeholders and allows for benchmarking against industry standards. By harnessing digital tools and bioreactors to optimize resource flows, they ensure maximum process efficiency. These cross-cutting themes integrate environmental, economic, and social goals, providing a robust foundation for BioAzul's long-term systemic success in the circular economy. Summary of circular economy strategies across European business practices. BioAzul's core circular strategy revolves around a high-tech nutrient recovery model designed to bridge the gap between urban sanitary systems and rural agriculture. Their approach utilizes advanced recovery technologies like struvite precipitation and the specialized Stuttgart process to capture nitrogen and phosphorus directly from wastewater streams. These recovered nutrients are then formulated into bio-based fertilizers tailored for the agricultural sector. A critical element of their strategy is the use of large-scale pilot demonstrations across 3 distinct European regions: the Baltic Sea, the Hamburg-Hanover metropolitan area, and Laxarkia in Spain. These pilots validate the technology's effectiveness across different climates and existing infrastructures, ensuring the solution is truly scalable. By adhering to the principles of reduce, reuse, and recover, BioAzul effectively closes the nutrient loop. This technological strategy demonstrates that specialized recovery methods can turn a significant pollution problem into a valuable resource solution. The main findings and impact of the P2 Green project highlight its success in delivering measurable environmental and economic benefits. One of the most significant results is the high recovery performance, with the technology successfully reclaiming up to 75% of phosphorus from waste streams. This drastically reduces the agricultural sector's dependency on mined resources and energy-intensive mineral fertilizers. Environmentally, the project has a major impact on pollution prevention by mitigating aquatic eutrophication, thereby protecting vital ecosystems from nutrient discharge. Economically, the initiative stimulates local growth and stabilizes fertilizer costs for regional farmers, making sustainable practices more accessible. Systemically, the project has proven that urban waste can be successfully integrated into rural agricultural cycles through multi-party collaboration. These outcomes provide a clear picture of how circular strategies can decouple business growth from resource depletion, offering a robust evidence-based case for the viability of large-scale circular transitions. In conclusion, the key takeaways from BioAzul's initiative underscore its role as a scalable European blueprint for the circular economy. First, their work proves that systemic innovation is achievable through multi-party collaboration, successfully linking urban and rural stakeholders to close resource loops. Second, BioAzul demonstrates that circular practices can achieve high market acceptance by strictly aligning with EU sustainability directives and waste treatment regulations. Their project serves as a practical model for sustainable nutrient management, showing how technological innovation can revolutionize traditional waste and agricultural systems. The success of the P2 Green project provides valuable knowledge that can be transferred across different industries and sectors throughout the European Union. By combining ecological regeneration with economic competitiveness and social equity, BioAzul provides an inspiring and proven solution for organizations looking to transition toward more sustainable operations. Their journey reduces uncertainty and supports strategic decision-making for a greener future. Thank you for your attention throughout this deep dive into BioAzul's circular economy practices. If you are interested in learning more about the KODECET project or exploring other good practice examples from our catalog, we encourage you to visit our website or contact our project partners.